In this video, you will learn to describe the 5 key skills of critical thinking, challenge assumptions, consider alternatives, evaluate data, identify key drivers, understand context.
5 skills. So now, how do you practice these skills? How do you actually apply these in your everyday life, on your job? How can you grow these and become a better critical thinker? And so these skills, these are not my skills. These came from a woman that I worked with at a previous job firm. And these 5 skills came out of her time, studying psychology and studying, how humans, make decisions. And so for each of these skills, on the next slide, what I'm going to do is I'm going to go through each of the skills, explain, what they mean, provide some additional work that examines, how can that be applied to cybersecurity, and how can you actually exercise this. So we'll start with challenging our assumptions. This sounds easy, but it's hard in practice. It requires questioning your mental model, questioning the mental model that underlies your reasoning. How do you do that? Because assumptions, oftentimes we're not even aware that we're making them. They're based on, our past experiences, thoughts and evidence, our personality. So oftentimes we don't even know that we're making an assumption. What I found is that it's very useful to bring in other perspectives, to talk to other people and start brainstorming and listing out your assumptions, and to continually do this, throughout the lifespan of your project, throughout the project timeline. Question your assumptions, gather more data, take a systematic, disciplined approach to this. And so what I usually do is I try to make a framework out of this. I try to put this into steps that are, distill how you would do this. And so step 1 is, explicitly list all assumptions. And again, this requires other people. Invite all of the stakeholders involved, whether, it's your project manager, colleagues, whoever. Have a brainstorming session where you start to list every possible assumption you could be having. And then for each of those assumptions, question them, examine them with some key questions. Why do I think this is correct? When could this be untrue? How confident am I that it's valid? What's my confidence level? And if it's invalid, what would the impact be? This gives you a way to start to triage your assumptions, and then now you can categorize them based on evidence. Is it a solid and well-supported assumption? Is it correct with caveats? Or is it unsupported or questionable? Unsupported and questionable doesn't necessarily mean wrong. It just means you need more data. And so after you go through this categorization, you refine, you remove, you collect additional data as needed, and you iterate over this. This happens naturally throughout the lifespan of your project. And so that is your key assumptions check. Number 2, so now we've checked our assumptions. Are there alternative explanations? Are there alternative explanations for behavior, for an activity? Like I said, our brains can piece together a situation with just a few bits of data, but the scary thing is that, if we fail to consider missing data or alternatives, this can lead us down the wrong path. We have to be able to consider alternative explanations. Avoid letting yourself become entrenched in one explanation. I can't tell you how many times this has happened to me, where I become so engrossed in one explanation that it turns out to be wrong because I fail to consider alternative explanations. And so, again, how do you do this? Brainstorming. Get more people in the room. Start, you need those different perspectives, because you need different perspectives of looking at the problem and different creative thought processes. I like to use the 6 classic journalistic questions as a framework for this, which I'll talk about on the next slide, to evaluate all different dimensions, and then also consider the null hypothesis. This is the exact opposite of what your main hypothesis is, and this is a good exercise because sometimes it forces you to look at a problem from a different perspective. So the 6 W's, again, they're very simple. You know, we all know these: who, what, where, when, why, and how. And I find that they're very useful for, you know, examining explanations or examining, you know, these alternative explanations. So, you know, in the case of, well, I like to use a threat hunt example. Who is involved? You know, who is the victim? Who is the target? Who are the stakeholders? Who's affected, you know, by the outcome of this? What is at stake? Whether it's data, whether it's a physical asset, what happened? You know, what is the problem? What's the desired outcome of this? Where did this take place? Does geography matter? Where is the infrastructure? Where is the victim? Where is the adversary? Does this matter? And again, when? Does timing matter? Are there key dates? Are there deadlines that we need to be aware of? And why are we doing this? Ask yourself that. Make sure you're solving the right problem. You know, also, what are the key drivers? What could be a motive? And how? How are we approaching this? Is it feasible? And then be detailed and specific. Really think through, you know, how you're going to, you know, think through each alternative and what that would entail and whether that's plausible. So again, examine alternative explanations. Look at them through the lens of these 6 different questions to characterize each explanation and examine it from different dimensions. So we've identified our assumptions, we've evaluated alternative explanations. Now we get to evaluate our data. This is one of my favorite skills. This is the crux of the scientific method. Assess the data against multiple hypotheses to see how well it fits. You know, if you've got a favorite hypothesis but the data doesn't fit, then you unfortunately have to let go of that hypothesis. And there's a few, there's a couple of points I like to make on this slide that aren't necessarily related directly to critical thinking, but I still think are very important to make. And the first, I'm going to start on the bottom. The first is that cyber data is notoriously hard to get, and oftentimes people don't realize that until they need the data. And this can be for a number of reasons, whether it's policy, privacy issues, you know, maybe HIPAA, GDPR, maybe there are reasons that, you know, your customer, your client, or whoever, you can't get the data. It could be that it's not been collected. You know, if your network is not instrumented to collect certain data, or your host systems aren't instrumented to collect certain logs, the data doesn't exist, and then you can't do anything. So what I like to tell people is to be proactive. Be proactive when you're setting up a new network environment, a new system. Establish a baseline for what's normal. Understand, you know, what's important on your network and what data you would need to capture in order to, you know, triage problems or to, you know, monitor its health and wellness. And so the nice thing about this too is that it helps you establish a baseline for what's normal. It helps you to see, you know, what does normal source and destination web traffic look like? What does normal endpoint activity look like? This allows you to, you know, this is key to anomaly detection. This is how you'll be on the lookout too for inconsistent data. So again, evaluating data. If the data is not there, it's not there. Be proactive. Be proactive in establishing good data collection practices. And skill number 4, so identifying key drivers. So again, key drivers are things that can significantly impact a situation, and they're not always technical in nature. So think about things if you're, you know, from a cybersecurity perspective, these obviously do include technology, so encryption, authentication, tools, frameworks, infrastructure availability, but they also include things like regulatory and political drivers, so privacy, GDPR, safety regulations, you know, intellectual property, supply chain, logistics issues, your employees themselves, you know, their training needs, their perspectives, their skills, and then your threat actors. You know, we always have that adversary, that other person. You know, what are their technical capabilities? What are their motives? What are their opportunities? So a nation state threat actor is going to have a lot more you know, financial capability and perhaps different motives than a script kiddie or somebody who's, you know, hacking at your server from a basement somewhere. So there are a number of different drivers that can impact your situation that it's important to be aware of because they're not always technical. And number 5, understanding context. So what does this mean? Context is the operational environment in which you are working. And so the context here at IBM is different than the context at a university, which is different than a context perhaps at another, you know, at a Microsoft or another company. And so context matters. Be aware of, you know, different perspectives of your managers, your colleagues, your clients. Ask yourself these questions. You know, what do they need from me? How can I frame the issue? Do I need to place their questions in a broader context? And this is where the notion of framing techniques comes into play. So you recall at the beginning of the presentation when I outlined the goal of this talk and also what I mean by critical thinking, that was a framing technique to ensure that we are all on the same page and to understand that we're all using the same vocabulary, you know, because this helps to avoid confusion and avoid problems down the line. So I love framing techniques as just a solution to, you know, mitigate problems down the line. So framing the issue, again, there's a number of steps that you can do to help you look at an issue or a situation more objectively. And the first is to identify the key components inherent in, you know, whatever the situation is. So what does this mean? Who or what are the key components? You break them down into component parts and start listing your key actors, key categories, and then from there start to identify the different factors at play. You understand the components. What are the driving forces? And again, this will allow you, going back to that driving forces diagram, to start revealing additional insights and relationships that you might not have been aware of initially. Now you can start to look at relationships. What patterns and relationships exist among different components and factors? Are they static? Are they dynamic? In the case of, you know, maybe doing a threat hunt investigation, often graphing databases may help here to help start to visualize different relationships among entities. In similarities and differences, are there historical analogies that you can fall back on? Have you seen, you know, similar patterns, behaviors, or a situation, you know, in a different context or in a different experience? You know, can you pull from that? And then redefining. Experiment with different ways to reframe your problem. You know, write down what you know, what you don't know. How can you look at it differently? Is there a root cause, perhaps, that you're not seeing? And so, going back to our elevator problem, again, just to remind us, we're managers of a high-rise apartment complex. You know, people are complaining that the elevators are too slow, and we've got a number of different approaches to fixing this problem. You know, I'm sure all of you came up with your own approach. You have your own thought process. This is a real anecdote. This is a real situation that happened, and what they ended up doing was installing mirrors. They installed mirrors, and the complaints died. All of a sudden, the elevators were faster. And this is a classic example of problem framing and how you can, by changing the problem space, now you're fundamentally changing the solution space. By installing mirrors, the problem wasn't that the elevator was too slow. The real problem that people are complaining about was that waiting is boring. It was boring to stand there and wait because, you know, that their minds weren't focused. They were focused on the waiting. By installing mirrors, now all of a sudden, people who are waiting for the elevator are distracted. They can look at themselves. They can look at other people. You know, they're not focused on the elevator. So rather than making the elevator faster, the solution space is transferred into shorten the perceived wait time. And that can be done a lot more simply and cheaply by putting up mirrors, playing music, installing art displays, things like that. So this is an example of this notion of problem framing and how identifying these different aspects of a problem can deliver like these radical improvements in spark solutions to a seemingly intractable problem. And again, this is why having that diversity of perception or of thought within cybersecurity is so important. So again, just to recap the 5 skills that I've outlined here: challenge your assumptions, refine as you learn more, consider alternative explanations, don't get entrenched in one explanation, evaluate data. Again, does the data fit your hypothesis? Identify the key drivers. What are the driving forces at play? Remembering that they're not always technical. They might be political. There might be personnel issues. There could be a number of driving forces, and understand the context. Understand the context in which you are working. Can you put yourself in other people's shoes? Can you reframe the problem so that the solution space is different?